Welcome back, everyone. Today we will learn the new lesson in the course of Pre-Calculus Math 12, Lesson Unit 1 and Lesson 2. The topic we will learn today is function notation of the transformation, or actually transformation notation of the functions. And I will show you the lesson today. We will examine the transformation notation for my PowerPoint presentation. I am creating this unit and realize that it's better to serve you on my presentation PowerPoint. Um, Function notation is not hard lesson. It's not difficult. However, because the size and a lot of notation, letter A, letter B, adding into the function, and we have to remember what type of transformation based on the function notation. Make sure that we interpret the given question asks us to transform the function, the image, undergone what type of transformation based on the notation that mathematicians um, created for us. So because of that, it could be confused if we don't interpret them appropriately. And that's why I create this MS PowerPoint presentation to serve you better. Before we get into the presentation, I would like to remind you about register your study with me online at mymathteaching.ca or visit my math courses online.teachable.com. So please bear with me a minute and I will show you, we will examine the transformation notation today together. Let me share screen with you. And allow me a minute to organize my presentation. So today lesson, unit 1, lesson 2, transformation of functions. We will explore transformations, notations, and practice exercise. Now the practice exercise, you will be able to do that if you register into my course. So for my first slide, I am talking about transformations notations. Any original f of x can be transformed into a new f of x as a vertical stretch of a factor of a. Example, I give you a function f of x, and this is the quadratic function. So you can notify this is the degree of the polynomial function, degree 2. And this is the quadratic function, 2x squared plus 3. If a equal 3, now the letter a stand in front of the function show us that this is the multiplication operation. It's not adding or subtract. So you multiply a letter a with the whole function. So if we have the a equal 3, all what you have to do is put 3 in front the bracket and multiply the whole thing, multiply the whole function. So the result come out will become 6x squared plus 9. So this is not so bad and obviously it's easy to remember. Let's get into the next slide. As the fact that you can have a vertical stretch, like from the first slide, we're talking about vertical stretch factor. So we're talking about the y-coordinate. So let's say you have a function with this shape, and the y-coordinate is short like this. And if you multiply the factor a with the y-coordinate, then you create this a taller image. So from short like this, it will getting taller. And that is we expanding. We also can compress the y-coordinate as well. So now in this slide, I'm talking about the new thing, which is we also can expand or compress horizontally instead of vertically like this. We can expand horizontally or compress the function horizontally. And when we're talking about the expanding or compressing the function horizontally this way, we're talking about the compression of the x-coordinate and not the y-coordinate. So the y-coordinate will stay the same, whatever it is, but the x-coordinate will be stretched or compressed. And this is in this concept in the second slide here. I'm talking about expand or compress by a factor of 1 over b. Now, why we reverse? Why we say 1 over b rather than just b? So remember, when you expand the y-coordinate by a factor of a, you multiply with the factor of a. If the factor of a is bigger than 1, let's say 2 or 3, then it will stretch. If the factor of a is 1/3 or half, then it will compress by half or compress by 1/3. And we're talking about the vertical stretch, so we're talking about the y-coordinates. Now, in this horizontal stretch of compress, the y-coordinates would stay the same, but we will create an image that expand the x-coordinate horizontally or compress it. And because the structure of the coordinate and the way we stretch or we compress, so for the horizontal, when we expand it, we make sure that it will be expanded by a factor of 1 over b and not b like a vertical stretch. So you can see the difference between two things. For the vertical stretch, we multiply with factor of a and we not reverse the fraction. But for horizontal stretch, if a notation give you b, when you compress or expand, you have to calculate it in terms of the fraction 1 over b. So it's very benefit to you if I mention this from my PowerPoint. You can see it very obviously. So given the function of x, for example, x squared minus 1, when it's transformed to y equal f, and you also notice the B letter here, we're talking about the horizontal stretch. We use the B letter, we don't use A. So A in front of the function stands for the vertical. But the B here inside the bracket and beside the X is mean horizontal stretch or compress. So the F of B of X when B equal 1/2, then this function will become 2x squared minus 1. And the reason because you will divide the x coordinate here by, you will multiply the x coordinate here with the inverse fraction. So instead of divide by 2, you will divide by 1/2, which is become multiply by 2. So it results in the answer is 2x squared minus 1. let's look at another example. Let's say you have a function f of x equal to x squared plus 3. When it's transformed to y equal f of b of x, if b equal 4, then your function will become, at this point, you will divide the b here by 4 because we're talking about the inverse of fraction. So it results into 1/2 because if you divide 2 by 4 and you reduce the fraction, it becomes 1/2 x squared plus 3. And notice that the number 3 here has no effect. And what you do is, if it's a horizontal, straight, or compressed, you pay attention to the coordinate x, not anything else. If it's a vertical straight, you will multiply with the whole function by the factor of a because this is the y function. But if you talk about the horizontal, straight, or compressed, then just the coordinate x will be affected by this transformation and not anything else, not the number 3 here. And you can see the differences between that. Let's go to the next slide. The next transformation, we will examine the reflection on the x-axis, such as f of x will become minus f of x. So when you have a function f of x, if the question asks you to find the transformation of the function of minus f of x, this negative in front of the function f of x here stands for the reflection on the x-axis and not the y-axis, because this negative applies to in front of the function f of x. So if you see the function original is f of x, and you see the negative in front, we're talking about the reflection on the x-axis. And in my first lecture, I have shown you some kind of transformation and how we sketch it. So you can reconnect it. If you register to my course online, you can reconnect my first video to this lesson and give you a continuous ideas for you to easy to understand. So given f of x, for example, if I give you the function f of x this is the radical function, the square root x plus 2. Now we're going to find the transformation of this function minus f of x. And the answer will be, you will apply this negative in front of the whole function. So square root x plus 2 will become minus square root x plus 2. Let's get into the next transformation. So the next transformation, we are talking about reflection on the y-axis. Reflection on the y-axis, such as f of x will become f of minus x. If you notice the function notation, you will realize that if we reflect over the x-axis, then our negative will be put it in front of the function. But if we reflect on the y-axis, then the negative here will apply to the x-coordinate and not the whole function, because this function is a y function. F of x is the same like y function. So therefore, the notation apply to the x-coordinate, and that gives you f of minus x. For example, if you look at my example here, if f of x equal minus absolute value of 1 minus x plus 3, then find the reflection of f of minus x. Now, This is the absolute function, and in this course, later on, you will examine some of the important function specifically of the whole as a whole lesson at the whole unit. But in this first unit, we will talk about the general form of on the function. So it could be a quadratic function, it could be linear, or it could be absolute function like this. I give you a varieties of the form of the function in general. So here you have an absolute function with the negative in front of the function. Now this negative is the original function already given to you. So we must realize that this negative is not the function transformation. This is the original function. F of x equal minus absolute of 1 minus x plus 3 is the original function. Now we're going to reflect this function on the y-axis and not the x-axis. So in this case, all what you do is let everything stay the same, minus still minus, absolute still absolute, number one stay at number one, but minus x, keep in mind that your x have a negative side. So this is the negative of the function. Your x actually originally have a positive side. But when you reflect it over the y-axis, you put another negative in front of the x value. So turn out we have two minus signs, which is 1 minus minus x, because you want to apply this negative in the coordinate x here. So that become minus minus x. And you know in math, when you have a negative in front of bracket, this will change this x become a positive. So the final answer will be minus absolute value of 1 plus x plus 3, which isn't bad at all. It's easy to understand, right? And I told you this topic is not difficult as long as we apply it correctly and appropriately. But sometimes we miss the signs, we miss the notation, and that's become an issue. So let's go to the next slide. So in this next slide, you will learn with me about the vertical shift. The vertical shift up or down by a unit of d, such that f of x will transform into f of x plus or subtract the unit d. So let's say you have a function with the y-coordinate like this, and you shift the function, you will move this function, the whole function, up. So the shape of the function is not changing. It's just like the translation. So you move the whole shape up by 5 unit or 10 unit. It's up to you. Or you can move it down by 5 unit or 2 unit. And we call that the letter D because it represents any unit. So if the D equal 2, you move up plus 2, you move up the function by 2 unit. If it's a negative 2, you move the function down 2 unit. Keep in mind that when you move, when you translate the function, the shape of the function is not changing. If it open this wide or it short like this, it keeps stay the same. So let's look at the example. Given f of x equal 3 square root of 5 minus x minus 5. Find an f of x plus 2. So we know that this letter D here stands for plus 2. And an answer is f of x will be equal 3 square root of 5 minus x. minus 5 plus 2. So you will add this number 2 into this function. But the way you add is you have to add it in careful way, right? Because you might think, oh, I'm going to add this 2 to number 3 here, or I'm going to add this 2 to number 5 here. And that's not going to work that way. Remember, the whole thing here is the f(x) itself. So when you add it to this function, this D letter only apply for the minus 5 here. And the reason because the form of the notation, if you have minus 5 here, it means this stands for the unit D. And so therefore, when you apply the transformation, you add into this number. Keep in mind that this number outside the radical function, right? The radical side is outside. And this number 5 is stand for the letter D. So when you add the 2 here, you add into the letter D here, minus 5 here. So minus 5 add 2 become minus 3. So in this way, you don't interpret it in a wrong way, and that will result in the radical, the same function, 3 square root of 5 minus x minus 3 instead of minus 5. So let's go to the next slide and see what next transformation will be. So the next transformation is horizontal shift to the left or right. So when we're talking about vertical, we're talking about move the function up or down. When we're talking about horizontal shift, we're talking about move the function to the left side or to the right side. So the whole function will not be changed, will be the same shape. All what you do is move it along the axis to the left or to the right. So let's examine this example. If f of x equals x squared minus 4, so again, this is the quadratic function. Find f, open the bracket, x plus c, close the bracket. Now, how do we distinguish between the vertical shift and horizontal shift? We know it by seeing the C, letter C here applied to the coordinate x, and that's why we put it in the bracket. So find f of x plus c when c equal 2, which is positive. Now, in this question, the answer will be f of x plus 2. All of this square outside and minus 4. So you realize that this is the x squared and not the x normally degree 1, but the x of degree 2. So when we apply this transformation, we change the sign from so if our C is positive, in the quadratic function, we realize that this negative is belong to the function itself. Sorry, it's the original function. So when we apply the positive in here, we change this positive become a negative because the quadratic function will shift it to the right if this C is positive. And when you shift the quadratic function to the right, the formula itself is a negative. So when you apply the negative into this positive, it will be negative. But if you shift the function to the left, then the C here is a negative shift. You shift 2 units to the left, so the C here is negative. Now negative with the negative formula will become a positive. So for the quadratic function, the side would turn out to be opposite side. And this is only applies especially for the quadratic function and not the other function. And that's why we need to um, be careful with this function in terms of the sign here. So if the C is a positive, it tells you the transformation is moved to the right. And if it's moved to the right, because the formula itself have a negative, so it turn out you apply the negative to positive, so it keep negative too. If this C is a negative, it means the transformation is shift to the left and require you to shift to the left. So negative with negative turn out to be a positive. And everything else stays the same. So x minus 2 on of this will be square. Notice that the square apply for the x coordinate. So regardless this x coordinate changing, the power outside the bracket applied to it. Let's go to the second example. If f of x equal x squared minus 4, find f of x plus c when c equal minus 2. Here you go. You see that in the second example, I show you a new f of x, which is now because the shift is negative, so it becomes x plus 2 squared minus 4. So I hope this clear now. Now let's go to the next slide and see what is the next information. So here we're talking about transformation vertical stress factor of A, horizontal stress or compress factor of B, vertical shift up or down by a letter of D, and horizontal shifted left or right by the letter C. Now we get into a new transformation, which is an inverse function. What is an inverse function? An inverse function happens when each coordinate interchange, when each coordinate of x, let me move my small picture, my small pretty picture. I'm not pretty, I'm just joking. I'm going to talk about an inverse function happens when each of x coordinates interchange with each of y coordinates, such that bracket x, comma, y. So when we put in this coordinate form, we have a comma and we have a bracket outside. Now, a lot of my students never put the bracket around. Sometimes they just miss the brackets, and that's not a good sign. When we're talking about the coordinate, we need to put it in the bracket, and that's the form of the mathematics notation. So x, comma, y, transform become y, comma, x. For r, if you have original is minus x, comma, y, then it's transformed into a new will be exchanged. The y here is positive, so you don't twist the side. If it is positive, it stays as positive. You just interchange their position. So the y here behind the x, now you change it become in front the x. So you interchange between the coordinates x and y. So x and y become y and x. And now the y is positive, keep in mind stay positive. This original here already negative of x. So when it change the position, it's still a negative of x. So basically the x will become the y and the y will become an x. And that will create an inverse function. So let's examine Actually, I should show you the image of inverse function. But let's keep this way. So combine on the transformations above the f of x functions undergone a chain as an f of x transform into a new, if you combine all of the transformation we were talking about before, then you can see that you apply this f of x will multiply with the factor of a in front the whole function. Inside, you have a horizontal of letter B here stand for horizontal stretch. So it will be A multiply with F, open the bracket B, open the bracket X plus C. So letter C here stand for the transformation horizontally. Close the bracket plus D. So as long as you see the unit D stand outside the function, that is the vertical shift, whether shifted 2 unit or 3 unit up or down. So here I show you the function notation of the whole transformation. This is the combination of all the transformation together. So this function undergone the whole thing changing. Vertical stretch by factor of a horizontal shifted left or right by the letter C, vertical shifted up or down by a letter D. So this is the combination. Now let's examine the image of an inverse function. So I stated here, the dotted line is the mirror line of an inverse function. So if you have, let's say if you have a blue function here, let's look at the blue shape here. So this function is like a wave, right? Blue shape. If you interchange, let me pick up the image right here and this is slightly a little bit from -1, but let's call this is the -1 right here. This point will become, if you draw a perpendicular line to this mirror line, then this point on the blue shape will become this point at -1. So you can see -1 of x will become -1 of y on the red wave here, on the red sketch here. So the sketches of an inverse function. So the coordinate -1 for x become a -1 for y. Sorry, let me go back. So let's say if you have a point here, right, stand on the mirror line. So because this point already on the mirror line, it will not change when you reflect over this mirror line. So this point is the intersection between the blue shape here and the red shapes because this point is stay the same. So this is like x is 2 and y is 2, stay the same. Now let's examine another point. Let's say if you look at a point, let me pick any point here. Yeah. So let's say if I pick a point here is the y-intercept, right, of the blue shape. And this y-intercept is 1. When it change to the inverse, this become x-intercept. So the y-intercept here is 1 will become 1 for x-intercept right here. And if you draw a line, this line will be perpendicular, which is form a 90-degree angle with this mirror line. And that's how we see the inverse function look like. And you can sketch them, right? Just draw a, a linear line perpendicular to this mirror line will create to you another coordinate. And when you join all of them, it will create the red function here. instead of the blue function. So I hope it's clear, and let's go to the next slide. Now, in the next slide, I said that there are much more in this topic that you will explore about. For example, given the graph of y equal f of x, sketch the graph of a question y equal 2f minus 1/2 of x minus 1 plus 1. Now, this, if you look at this information, you can interpret this transformation as vertical stretch of factor 2, horizontal stretch, not compressed, because we talking about 1 over minus b, 1 over b. So it will result in a 2 of 2x instead of half of x like this, right? So it reverse, you can see that in front of the x. And the minus 1 here, this result, I will show you how we do the transformation. We have to factor out a little bit, but that will go to the next lesson, and I will show you how to do that. But just this one show you that it could be complicated if you don't interpret these coordinates properly, these transformation properly with the function notation, right? So for the question B, it provide you y equal minus f, 2 minus 2x minus 2. So we have to factor out this a little bit, and we can interpret it as a reflection over the x-axis. And this could be, if we factor it out, it will be a horizontal compress of 1/2. And we're supposed to shift this function down, shift it down by 2 units. So this is the combination, how we interpret it. And I think that is for today's lesson. So this is a short video. I hope you enjoy my video. And if you register in my course, you see these are a very beautiful MS PowerPoint presentation that help you to remember the topic you learn. And I will show you on the, so here, if you register to my course, I will, okay, let's stop. So you will see you can have the practice exercise. So this paper will allow you to sketch an inverse function. And this exercise will help you to know explore each of the transformation. And in another exercise, you will look at the graph like this, and you will be able to write the function equation for each graph. And another exercise, given you the original shape, you will have to look at the function notation here, and you sketch according to this function notation. So that is the exercise you will practice with me in this course. So you look at the function notation as I just showed you, and I interpret it to you, right? Look at it, and you will sketch it according to the notation given to you. Now, the next exercise might be, let's see how it looks like. So this is another exercise here. Let's say given you the function, and you sketch this original function to transform it into any of new function notation given to you. There is a coordinate transformation, and that will appear in our next lesson. So our next lesson, I will show you how to apply the transformation to each coordinate yeah, to each coordinate you're supposed to calculate. So let's say you have a function, um, and here the question say y equal f of x has a point a comma b, match the function on the left with the point on the right. So all of this exercise is actually is not hard. It's interesting if you have the right guidance to show you, and you can do it. And um, again, I hope that you will enjoy my math teaching online, and you will join me sign up to my math course online. Currently, I am creating pre-calculus math 12, and you will see a lot of interesting topic come up, such as solve the equation, solve the function. You will learn the whole radical function, absolute function, rational functions with me, how to sketch them using the hand sketching, and check by the calculator. I don't want to use a calculator as the replace for technology replace mathematics, but I would rather use technology as a tool to help the mathematics, um, to help you to comprehend the concept of mathematics, but not replace it. Um, that's my teaching philosophy. Um, I believe each of the topic, each of the subject have its own role, play its own role in our life. So this the branch of mathematics is another branch of uh, not the same like technology. Technology can be changed and out of date over the times. Mathematics never be out of date. Our mathematician on the Greek philosopher before, um, on over Asia, Europe, already discover about the number pi, um, that we use on the time right now when we're talking about circle. And on the formula, like the Pythagorean theorem, it's never changed. It stays the way it is. And on the geometrical roof, what we applied in solving equation and showing how the roofing the roof, um, symmetrical transformation, or anything like we learn in geometry. It's never be changed. And that's the beauty of math. And I hope that you will enjoy when you learn math with me online here on YouTube, or register to sign up to my math course. You have access of all this knowledge that help you in details, concept step by step. And we I now keep in mind that when I create the lesson plan, I have to research, and I have to know which one is connection to each other, which concept is a continuance of logical sequence. I'm not going to just randomly pick this one and join to the next lesson. So my lesson, I have to have a knowledge of what concept I should show you first. And that is the job of the teachers. We should teach you in accordance with the mathematics language. So when I design the lesson plan, I know when I'm talking about transformation, which lesson I show you first. Do I show you about the change in coordinate first, or just introduce you the type of transformation before I get into a new lesson? And that's the main idea. You understand it by the sequence, logical sequence of math. And I will give you, I have confidence to give you a right tools to learn. So hope that you will enjoy our online learning journey. And if you sign up to my courses, if you have any question, you can ask me register in advance on Zoom, and I will set up the Zoom schedule um, for us to work on one-on-one. So thank you for watching and bye for now. Stay tuned for our next lesson. I will show you how to calculate the coordinates, given the coordinates, apply the transformation, how that coordinate will change into another number, the magic number. So thank you for watching. Bye for now. I hope you enjoyed my video. Have a good day, everyone.